Okay, here we go. So again, I always try to model what I would do if I were actually taking the test. I've never seen the problem before. It says oil is leaking from a pipeline. Probably circle oil. On the surface of a lake forms an oil slick whose volume, keyword also is increases. Volume increases at a constant. Keyword is always rate. So constant rate, 2,000. I get points for units. I'm going to circle that. Cubic centimeters per minute. The oil slick, develop the habit of when you hit a period, kind of pause and make sure you haven't missed something. So oil leaking from a pipeline. Okay, good. The oil slick takes the form of a right circular cylinder. So, cylinder. So it's like you picture the oil slick as a big circle with thickness. The radius and the height are changing with time. So here's the height. Here's the radius. And they give us a formula, so I'm going to keep track of that. Anyone have comments or questions so far? Please.
Why do you circle oil?
I think because I remember all those problems that deal with the number of mosquitoes, the oil, the water. In some ways, maybe it would be better not to worry about the oil because it doesn't really matter. All I care is it's something whose volume is increasing. That was a good question. Good observation, because it really turned out to be the least important of all the rest. So. Anybody else? Please, Chris.
How can oil be leaking but increasing?
So the idea is there's a pipe, and oil leaks from the pipe, and this is what increases. So the oil in the pipeline, they're not talking about that increasing. They're talking about the oil on the lake. Gets bigger and bigger as the leak keeps spilling onto the lake. Pebbles. Anybody else? All right, first question says, let's go here, there's a little more space to work. Clear that off. Okay, at the instant when the radius of the slick, so when the radius is 100 centimeters, I'm going to translate that into a statement. So R is equal to 100. And the height is 0.5. So we've got height equals 0.5. The radius is increasing at a rate. So that would mean dRdt is 2.5. And apparently I do such a good job at simulating never having done the problem again. I find myself doing it completely different than I did last period. So I feel pretty good about my performance up here, so thank you for your support. No, it's actually working pretty well. They just somehow mentally try to tell myself I've never done it before, because this is very different than last period. So, I don't usually worry about units until I get a final answer, but I'm always remembering the final answer to include the units. 2 for that. There you go. Let's see. The rate is increasing this. At this instant, what is the rate of change of the height? Okay, so seeing that they gave me one rate and they want another, it's a related rate problem. That's what I suspect. So I'm going to go down that path. So I'm supposed to draw a picture. Well, that was the cylinder. Height and radius. I'm supposed to draw Danica's chart. So I'm supposed to have an amount and a rate. And I'm supposed to read and write down the rates. So I'm going to do it again. Let's see. The instant when the radius is 100, that's not a rate. Oh, please, Eden.
Sorry, I just, how is that radius increasing? What is that?
So what it means is you start out with, think of it like this, as the oil leaks onto the pond, the lake, initially the size of the slick is maybe like that cylinder, but as more oil leaks, it gets to be this size. So the radius of the...
So I didn't think this was one oil so
Oh, no worries.
like, and
Right, it's just like taking oil on a lake and just dumping it on the lake. It will float on the surface.
okay, I thought it was like in like itself.
Right, they're just saying pretend that as you look at that oil spill, to make the math simpler, just envision it as being some circle with thickness. And as the spill gets bigger, they're telling you that the radius of the slick is increasing by this rate. And the height is you're supposed to find how fast the height increases. Good question. You should write them a nasty letter and say you wrote a biased question because we don't really deal with oil slicks in Utah, so we feel like the question is unfair. Like those questions that talk about coffee pots and such. So there actually have been several of those over the years.
So we can't tell the problem that the rate changing the height is increasing.
Not yet. Not yet. We have to find that rate, but we don't know yet. Good for Colette and Eden. Yeah. Okay. So amount. So I'm going to read again. Let's see. So I'm supposed to write down the rates that I read about. So I read about the rate of increase of the volume. So I'm going to write that down. So dVdt. That rate is 2,000 cubic centimeters per minute, which means the amount would be the volume itself. Let's see, I also read about the radius rate, so that's drdt. That's equal to 2.5. Please note, okay, the pace you see me working the problem, this is an adequate pace to get a 5. I'm serious. Like, you don't rush on the AP test. You don't, it's not like the ACT. You're not trying to get everything done as quick as you can. Just be methodical. You'll save mistakes. You can solve more problems that way. Just be methodical. Let's see. So that means I've got a radius here. dHdt is the third rate that I read about. They want me to find that one. So that would be h. So according to the acronym now, I need an equation that involves the amounts. That's what the EA stands for. They gave me that equation. It was V equals I R squared H. I'm supposed to take the derivative of that equation with respect to time. So that gives me dV dt equals pi is a constant. Now I have to use the product rule. So it's H. The derivative of R squared would be 2R dr dt plus R squared dH dt. Okay, questions to this point, please.
I can't remember if derivative if that's just supposed to be memorized or if
Oh yes, thank you. Kind of both. So the acronym is the part that we've memorized, that when we get to the D, we're supposed to take the derivative of the equation that we created. The reason we do that is because that's how all related rate problems work. You start by saying, hey, somehow the rates are related. If the rates are going to be related, the amounts must be related. When we say related in math, we mean they fit in an equation somehow. So here's the equation showing me how the amounts relate. Does that make sense? You take the derivative of the equation, which shows how the amounts relate, you get a new equation showing how the rates relate. That's why it's called related rate. Does that help? So it really is a combination of, remembering that the D is to take the derivative, but the Y is fairly straightforward once you kind of think about it. So, 2 points. Pebbles. Anybody else? All right, so I got to here. Hey, habit. Look, when you're doing the AP test, do some work, reread. That way you don't end up answering the wrong question. You don't end up forgetting to answer something. So just go back and read it again. At the instant when the radius of the slick is 100, I got that. The height is 0.5, and the radius is increasing, 2 got that. At this instant, what is the rate of change of the height? So they want me to solve for dH dt. So I need to isolate that. So that means I have dV dt is going to equal, I've got to distribute the pi, 2hr dr dt plus pi r squared dH dt. And let's see, trying to get the dH dt alone. So that means dV dt subtract pi 2hr dr dt all divided by pi r squared. That will equal dH dt. Questions for anyone, please?
On that question, so on mine, I have 2RH next to the derivative of the radius, which would not be unfair, and then the R has to be next to the derivative.
No, it doesn't matter. So when you have several things being multiplied, the order is irrelevant. So I literally could have put the pi 2hr in the dr dt in any order you want. It's still perfectly fine. Oh.
So, I got the wrong answer. I'm trying to figure out why. Would plugging in the numbers divided before fully isolating the HTTP, would that be the wrong answer?
No, that's totally legal. Don't ever plug in the numbers before you take the derivative. So I can't put numbers here, but if you want to plug in the numbers here and then do the isolation, it's totally fine.
I have a function on my calculator that allows me to just plug in numbers and algebraically just get an answer. Is that fine when I'm using my calculator?
Like you're okay. Like it'll isolate this for you.
What I did is I plugged in the numbers in parentheses with the first equation, and then I put that in my calculator, and it gave me the variable that I was using in the equality.
Oh, gotcha. Interesting. I don't think they would penalize you for that because the calculator is legal, and it is this particular problem is a calculator-based problem. So I don't think there's a penalty. Who's your teacher last year?
Rocky.
You probably wouldn't know. I don't think so. I'll try to remember to ask a couple other teachers just to make sure. But I've never seen them penalize you as long as you're using a legal calculator.
I did write out like me plugging in the numbers, and then I just didn't isolate each.
Yeah, and actually, if you look at the way the scoring guide is laid out, they gave 1 point if they could see in your work that you correctly recognized that dV dt was 2,000 and dr dt was 2.5. This part you would have had to have done by hand, finding the derivative. So they'd expect to see like this right here. But then they're just looking for the correct answer, so it should be fine. If I don't remember to ask, keep asking. Like when you see me, just say, have you found that out yet? So it will help me if you just keep reminding me, Chrissy. Anybody else? Two for Chrissy.
How do you get to that?
To here.
Wait,
No, keep going. Oh, to this one?
Yeah.
So now we just plug in the numbers. So we say dV dt is 2,000. Let's see, 2, height was 0.5, radius was 100, dr dt was 2.5. All of this gets divided by pi, multiplied by the 100 squared, and all of that is supposed to equal dH dt. And I would stop there. That's a valid answer. Don't do more, because if you do more, you take a chance of making a mistake. Plus, it takes time to plug that in. So just stop. That's full credit. No simplification required. You don't have an answer to check, yeah. No, I get you. So yeah, homework, that's why we work it out, because we want to check it, but we don't need to.
So for the grading, are they only
Let me show you the statement. One second, John. Two pebbles for this. Just gotta get to my computer. Let me show you what it says in the instructions. And you get a copy of these instructions when you take the test. It's just that on the day of the test, you don't necessarily remember to read the instructions super carefully. But here's what the instructions will say. This is the actual booklet. Oh, I think I told you this one day about how the Scantron's kind of weird. So here's one side of the bubble sheet. Notice how it's kind of a purple color. And then the other side is blue. That's why they number it funny. So the non-calculator multiple choice will go 1 to 30 on this side. And then you flip it over and then you go 76 to 90 on the back. So the proctors can tell that you're using the correct side. So here's all the multiple choice questions. Here's the calculator multiple choice. Here are the instructions for the free response. This is what I wanted to read in answer to Anna's question. So here's some key things. You are permitted to use your calculator to solve an equation, find the derivative of a function at a point. This answers Kersey's too, I think. You are permitted to use your calculator to solve an equation. That's what you did. Find a derivative of a function at a point, or calculate the value of a definite integral. However, you must clearly indicate the setup of your question, namely the equation, function, or integral you are using. So you had done that, Kersey, because you have this equation written down, and you said you even wrote it down with the numbers plugged in. Mm-hmm. And so then you just write down the answer. It should be fine. Or if you're nervous, you can say, oh, solved using my calculator or something. Does that make sense? Then here, use other built-in features. You must show the mathematical steps necessary to produce your results. Okay, here's the part Anna's asking about. Show all of your work, even though a question may not explicitly remind you to do so. Clearly label any functions, graphs, tables, or other objects that you use. Justifications require that you give mathematical reasons and that you verify the needed conditions under which the relevant theorems, properties, definitions, or tests are applied. Your work will be scored on the correctness and completeness of your methods, as well as your answers. Answers without supporting work will usually not receive credit. So they're looking at these here on it to give you the points, but they are looking to see if you're using the equal sign correctly, to make sure you haven't written something that's not true with the equal sign. There's not per se a specific necessary strict method you have to follow, but if you look at the work that's on the board, there are no errant equal signs, like declaring something to be equal that isn't. There's nothing just kind of floating around. Things are organized so it's easy for the grader to see what you're doing. So they're looking for that kind of thing too. Anybody else? Awesome. Next one. I'm going to leave this writing to save a little time. Okay, I started reading. The recovery device arrives on the scene and begins removing the oil. I probably circle removing. Got to keep track of what adds and what takes away. That's always important. The rate at which oil is removed is this. So this is the rate which causes the volume of the oil to go down. It's the taking away rate. Let's see. Oil continues to leak at a rate of 2,000. Okay, this can be confusing. You've got to keep straight. You've got oil leaking from the pipe, but that leaking oil makes the volume bigger. But you're not talking about the oil in the pipe, you're talking about the oil in the slick. So the oil gets bigger at this rate, the oil gets smaller at this rate. that's why I wrote down the rate of change of the volume, just like many problems we practiced, is the rate which causes the volume to increase, subtract the rate which causes the volume to decrease. Questions? Please, Rachel. Can't say it better. Two couples. Anna, please.
I guess that it increases at 2,000 cubic centimeters per minute, but when you write it out in an equation, why is it just a solid number of 2,000? You don't
Multiply
by t, which is 2 minutes, so like each minute.
Gotcha. The difference is this. The rate is always 2,000 cubic centimeters per minute. So at time 0, that's the rate. Like we literally see oil coming out at that rate. Let's go 3 minutes from now. Do you still expect to see this rate of oil coming out? If you put a t onto that equation, right, the rate would be going up. At time 3, you now have 6,000 cubic centimeters per minute.
The rate is not the actual amount.
Correct. This is not an amount. This is a rate. Now, because the rate's constant, it's easy to figure out the amount. You can say, hey, after 1 minute, on how many cubic centimeters will have flowed out? 2,000. After 2 minutes, 4,000. After 3, 6. But the rate itself is still just 2,000. You see the difference? Two couples. Please.
So for finding the minimum and maximum, it, or not it, we find C will have a maximum like.
So let me say it back to you because you're just remembering a tiny bit wrong. So, because I know what you're trying to say, but it's coming out wrong. So I'd rather. There you go. Say it again. Now say it.
We will have a maximum. The time of change is or at the beginning and or at the
I'll say it back to you. Okay. So the theorem you need to get memorized a little more strongly, the min-max theorem, is that the max of V will occur at the beginning of V, the end of V, or at any critical point of V. Well, the critical points of V occur when V prime is 0. That's why I wrote down V prime.
Right, yeah, I understand that, but so did you like use the calculator to find 0?
Absolutely.
What do you, I just can't remember when it doesn't give you an end point where you stop.
No worries. So what I did, and just keep talking, I'm not getting your questions here. So I wrote down V prime, and I graphed V prime on my calculator. And I used the 0 function to find that spot, which turned out to be 25. With me?
I got that one.
Oh, awesome. So I wrote that down. I always write that down because they almost always give points for it. So I wrote V prime of t is equal to 0 at time equal 25. And sure enough, they wrote it a different way here. They say, did the student consider the time when R of t is equal to 2,000? Which I did, just in a different way. So that would get that point. Question? I think that's valid. I prefer this way. I think it communicates better. But I think that would be valid. I don't think they take away points for that. I think if you say, you know, like you'd write this, and then you'd write V of 25, sorry, V prime of 25 equals 0. I think that's okay. It is equivalent to that. Somebody else had their hand up. Oh yeah, okay. What I noticed next was I could do integrals, but I can't, like you said, they didn't give a window. Like time goes on forever. So I just guessed 100 and said, well, the trend seems to be heading this way. Then I thought for a minute, wait a minute. Root t just gets bigger and bigger and bigger. So when you start this thing, you've got 2,000 minus 0. That's why this is 2,000. But this gets bigger and bigger. Eventually they're equal. That's this time. As this keeps getting bigger, it gets more negative. So I'm feeling safe now. Questions? Awesome. So rather than do an integral, I just read the graph of v prime and said, hey, look, this is v prime. V prime is positive, starting at time equals 0 all the way, but not quite to 25, because at 25 v prime is 0. Therefore, v of t is increasing on that interval. I made these open circles because my thought was right at 0, it's not really increasing yet, but right after that it is. So, questions? Then I said v prime is negative for all time after that. So that means v of t has to decrease for all time after that. Again, I have the habit of rereading a lot. So I wrote some stuff down, I went back and read again. And I said, okay, the first part of this thing is just information. The question is, find the time when the oil slipped, the time. All they care about is the time. So I got it. V of t has to be greatest at this time. And that would give me all 3 points. Questions? Go ahead.
So the reason we don't do an integral is because they didn't give us
The end time. There is a way you can still use an integral. Like you could do an integral to find the value at 25. They don't give us how much there is at the beginning either, though, so that's a little weird. So this does fit a bit better as far as my justification. So, 2 points for Colette. Please, go on.
But still, how do you know that 0 is greater?
Oh, it's because from time 0 to time 25, the volume's going up. No worries, that makes sense. 2 for Lauren. Okay, last one. What else creeping up on us? By the time the recovery device began removing oil, 60,000 cubic, so there's how many there were at time 0. There's 60,000 cubic centimeters of oil already leaked. Read carefully, don't read fast. It says write, but do not evaluate. There have been no greater words ever written on the AP test. It's like, hallelujah, I don't have to do anything but write it down. Please.
Would you get in trouble or disappointed if you looked down and saw that 60,000 was where it started to use that?
In the previous one?
Yeah.
I don't think so. I think that would be okay. I don't think they've documented that. So it's the fundamental theorem. If I integrate v prime, I find the change in v. I rearrange, I have my answer. Okay, before the bell rings, I wanted you to look at the scoring here. As I said before, you're going to perform how you practice. So if you're very strict in practice, you'll get a better score than you even thought you will get on the actual test. So don't be lenient with yourself, but just show me. There's 9 points here. Every point you did on your own without anyone helping you, you get 2 pebbles. Points you earned with help, you get 1 pebble. I'd like you to show me in your hands the points you earned without help. If it's 0, I don't care. I just want to know. It's like you just show me how many points you earned without anyone helping you. And again, 0 doesn't matter. The key is to figure out where you're at and do what's necessary to get better. So good work. Thanks. Mark down your pebbles.